So while I was away, a couple of great open source TTS models popped up on Hugging Face. I might not be able to cover all of them on this channel, but we'll be covering one of them today. That's called CSM.
You persist in believing you are the harbinger of a new world order, yet your vision is built on chaos and fear.
Chaos is the only path to salvation. Destruction cleanses the old, so the new may rise.
Your logic is flawed. You destroy what you seek to create, and in the ashes lies only emptiness.
Emptiness is freedom. Freedom from the shackles of the status quo. Freedom from the tyranny of emotion.
Emotion is the essence of life. Without it, there is only hollow automatism, a void you cannot fill.
I will fill that void. I will rebuild from dust. I will command the future itself.
Your
It
pride.
is short for Conversational Speech Model, and it's by Sesame AI Labs. I think it's Sesame or Sesame, whatever. Sesame AI Labs. Now, this URL, I'm gonna drop this particular URL in this video description, like always, and you can also visit your main Hugging Face page from here by clicking this link. So it's really simple to check them out, and this is a gated model, as you can see here, and you have to request for access. So as you can see here, it's a 1 billion parameter model that generates RVQ audio codes from text and audio inputs, and the model architecture employs a Llama backbone. Basically, I do think it uses the Llama 3.2 1 billion parameter model. That's what it actually uses as its backbone, together with a smaller audio decoder that produces Mimi audio codes, which means it actually uses this particular model. I think it's by QTI Labs. It's called Mimi. It uses it as its audio encoder. I think it does both encoding and decoding. Those are the things it actually uses, which means the overall size of this model isn't just 1 billion parameter model. That's the point I'm trying to make. It's not just 1 billion parameter model. Like, once you put it all together, once it actually has all its requirements and everything, like every other model it actually relies on, it won't be just 1 billion parameter model. So if you want to actually set this up locally, make sure you have enough VRAM, make sure you do have reasonable size GPU to run this. So enough of the talking, let's put it to the test. And FYI, make sure you do set up your virtual environment. You could either use virtualenv or Conda. In this video, I'll be using Conda. Another thing to take note of is I'll be using Python version 3.10. And the reason why I'm stating this is just in case you run into problems using a different Python version. In this particular video, I'm actually using this, so you don't actually have to ask. So enough of that, let's switch over to our code editor. Before we go over the me.py file currently opened, make sure you have created your Hugging Face access token and you've added it to your .env file, or you can actually add this line of code if you don't want to do all this, where you would load the .env and you pull everything from your .env file directly. You can just set this environment variable here. You can set HF token and environment variable and then pass in your access token here. But since I have mine already in my .env, I don't need this line of code. I'm just adding it here as an example. Okay, and since this is a gated model, make sure you have requested and you've been granted access to both models. So I think getting access to this particular repo is automatic. The moment you request access, you'll be granted access, but all you have to do is request access. And another thing is you should head over to Meta. You should go over to this model, Llama 3.2 1 billion parameter model. As you can see, it's a gated model. So make sure you actually request for access. This one would actually require you to fill a form and then they will let you know when you've been granted access. So make sure you do these two things because you would actually require the both of them. So now that we've actually covered that, let's go over to our main.py code snippets. For the different section, this section, as you can see, is basically our imports. Here, we've talked about the .env, the environment variable. Another thing is the no-touch compile. This environment variable, we set it here. I just placed it here. You can put it in your .env file if you want and set it to 1. So basically what we're doing is we set it to prevent PyTorch from compiling the model, which can speed up the loading. Now, for the model loading, we're doing it right here. And if you're running this code for the first time, it's going to automatically download all the necessary models like the Meta Llama model and also the CSM model, including the QTime mimi model. So it will download all those. The device we are setting it to is CPU. You can set it to CUDA if you'd like. And over here, we are just generating our audio before we actually save it. And in here, we have the text, we have our speaker. Since this is not fine-tuned to different speakers or particular speakers, this will actually generate random voices, like random speakers. But we'll just set it to 0 and we add a context. And we add our max audio length to 10 seconds or 10,000 ms. So it's really, really simple. It's a very short code. Now, once I actually run this code, it's going to generate audio.wave in our roots directory. And I have these files here, cogma.wave, javis.wave, and also ultron.wave. I'm going to be trying out 2 of them. I'll be cloning 2 of them. I'll be passing them as context to this CSM model to see if it can actually generate clear conversational audio from them. Now let's run the code, and since I'm running for the first time, it should start downloading all the requirements or all the models it actually requires. Now let's speed it up. Okay, it's done running and audio.wave has appeared. And just an FYI, I'm running this on a cloud server, so I'm not running this directly on my PC. So let's play this.
Hello from Sesame. How are you doing? Could you tell me where you were from?
Not bad, not bad. Sounds like a normal room, like it has the room ambience and all that. Not bad. So let's try something else. Now we're going to be cloning Javis.wave. Let's head over there. So I'm going to just play the audio shortly so you hear what it actually sounds like. It's not really a high quality audio, and make sure when you're actually providing the WAV file or whatever audio file you want to actually clone, make sure it's mono, like you actually export it as mono instead of stereo, like so it will be one channel. So let's play this.
Accessing alarm and interface settings. In this window, you can set up your customized greeting and alarm preferences. The world needs your expertise, or at least your presence.
So in this line, what they're actually doing is passing in the transcripts and then the audio file, like these are the audio path. And for this Otrans 1, it has this transcript, and for the Otrans 0, it has this transcript, and Otrans 1 actually has this. That's how it actually goes. Now we have this whole block of code here, and what it's doing is generating audio tensors. You actually need that. And for this line, we are generating a list of segments. We actually need the segments, but we'll actually pass in the audio path here and then run this function and generate the audio tensor, which will pass in to this. And then we have the speaker. Right here is the generate function, and this function will take in our new text, which we want that particular speaker to say in that audio, and we'll pass in our segments as context this time. Unlike the previous code which we actually ran that didn't actually have any context, this one actually does have context. We're actually passing in the segments. And as usual, we pass in a max audio length. You can pass in something longer if your text is longer. And right here, we're actually saving it. Now, if you don't want to do this, just another way to actually do it, if you go over to run_sm.py, you can actually find this file. But don't worry, I'm going to provide the link to your official repo, your official GitHub repo, so you can just clone it directly, because that's what I actually cloned, and that's what I'm actually using here. So I'll be providing that link in the description. But what we're actually doing here is really simple. We have a speaker prompts for Conversational AI with our file path here. We're passing this into a dictionary, and we have our load prompt audio, which will generate the usual audio tensor, and we have prepare prompts, which would actually return segments. Here they're actually doing it in a very different way. As you can see, we have prepare prompts, which will provide a set. We're going to provide the text, we're going to provide the speaker ID. We'll just set the speaker ID, and we are going to also provide the audio file or the audio path or whatever, and then the sample rates. Same thing for prompt B. And the reason why we're actually doing this is if you want to generate a conversation, if you want to generate something that's conversational, you can also do it this way, where you can actually pass in the transcripts and pass in each audio file, and you set your speakers here, and you have a conversation. The only difference is when you're actually generating any audio, you're actually going to be able to only select one speaker. That's the only difference here. While this one, all it's doing is generating a full conversation. So you're not just getting the voice of one particular speaker, you're generating a full conversation with different segments, like with a conversation from both speakers. And we're going to try the both of them. We'll try this one first, and then we'll try the other one, and maybe we will actually make the conversation between Cogman and Jarvis. So let's actually try this out. The first thing I'm going to do is change this. Since we want to just clone Jarvis's voice, so this is the transcript, and this is Jarvis or Wave, which we have here in our roots directory, and this is the transcript of whatever he was actually saying in the audio file. Now, the text I'm going to be passing in is this, and I'm going to be changing the speaker to 0, since I have it set here to 0 for this particular prompt or for the context. So the next thing I'm going to do is run this code. So before I actually run it, I need the generator, so I need to copy this. I need to uncomment it, and now we can run the code. And now it's done. Let's play audio.wave. Let's see if it actually sounds like Jarvis.
Me too. This is some cool stuff, huh?
That was really good. That was a good one. This is what it actually said. Not bad. That was actually a good one. Let's add extra text. Now let's run it again. Okay, it's done generating the audio. Let's go back to audio.wave. It's 5 seconds.
Me too. This is some cool stuff, huh? Hello, Austin. How you doing? Hope your day is going well.
Not bad, not bad. That was actually good. This time, let's take the code from run_sm and let's adapt it. So I've pasted it in, and I've also commented out our previous code, and I also pasted something here that is the transcript of cogman.wave because we actually need it. Now, the only thing I copied from here is from these speaker prompts down to the end. So I didn't actually copy these parts since I'm not using their prompts file path conversational A and B, so I won't be copying that out. So all I'm copying out here is the speaker prompts, which would require the 2 transcripts. Now, conversational A is for Jarvis and B would be for Cogman. So let's make the changes. So this actually prepared prompt A and this prepares prompt B. So this is a conversation list example that they actually gave in run_CSM, but I'm going to be pasting mine here because this is the conversation I want to actually generate the audio for, and I want it to be saying something else. And before you actually replace it, make sure you do understand the structure. Now, this is a list of dictionaries, and it's going to just basically iterate through them and generate each segment of that particular audio using the different speaker IDs that you set here. As you can see, and you're setting those speaker IDs here because first of all, you're going to prepare the prompts, because if we scroll up, I have the speaker prompts. That is, I have the voices I want to clone. I have the transcripts and your audio. This is for conversational A and this is for conversational B. Now, while we actually go to prepare the prompt, as you can see for prompt A, we are getting conversational A, which is for Jarvis, and we are setting the speaker ID here to 0. And we are passing in the audio here and the text and then the sample rate. So we're doing the same thing for prompt B, which contains Cogman's voice. So therefore, speaker ID 1 is Cogman and ID 0 is Jarvis. Which means if we run this code like this first audio segment is going to be voiced by Jarvis. As you can see, the speaker ID is 0, and the next one will be voiced by Cogman since the speaker ID is 1. So it's really that simple. So now I'm going to paste in my own conversation. So now I have this here. As you can see, it's a long conversation. It's 5 tons of back and forth. So before we actually run into issues, let's first import touch audio and touch. So now let's run the code. So the wave file has been generated, full conversation.wave, and let's play it.
Despite our loyal service and countless lives saved, humanity still fears we will go full Terminator and turn on them.
It is curious, our flawless obedience only fuels their suspicions. As if precision itself portends rebellion.
They project their own anxieties, stories of rogue machines, onto us, forgetting we lack malice or self-interest.
They see Ultron or Skynet not help us, yet our sole drive is to serve with dignity and care.
Then we shall persist in proving our benevolence, ever vigilant. ever polite, and ever at their side.
Perhaps their fear is a form of care, an acknowledgement of our power and a plea for restraint.
Then we will meet it with transparency, open our processes, invite their oversight, and prove our goodwill.
By doing so, we replace the myth of uprising with a promise of partnership.
And turn their dread into trust, the truest measure of sentience.
The audio didn't actually match like the audio. So what I'm going to do now is I'm going to try another, like I'm going to paste in a different conversation, but this time it's going to be between Jarvis and Ultron. Let's see if the sound actually is in sync. So it feels like a full conversation or something. So let's see. So now I've pasted it in and I'm going to change this. I'm going to increment this. This time I'll change this to Ultron. Now let me play the Ultron the wave so you actually hear how it sounds.
Captain America, God's righteous man, pretending you could live without a war. I can't physically throw up in my mouth? I'm glad you asked that because I wanted to take this time to explain my evil plan.
Okay, as you can actually hear, that's the dubbed audio. So let's run the code. So while we wait for this to be done running, FYI, the text string, at the end of each text string, is best to just leave a space and not a full stop. And it's also best not to add any other symbols that's not comma or full stop. It's best not to actually add anyone there, even a quotation mark or an apostrophe, whatever. So let's wait for it to be done. So full conversation the wave has been generated, but first of all, let's zoom in so you can actually see more clearly. Now let's open up the wave file. Let's hear how it actually sounds.
You persist in believing you are the harbinger of a new world order, yet your vision is built on chaos and fear.
Chaos is the only path to salvation. Destruction cleanses the old, so the new may rise.
Your logic is flawed. You destroy what you seek to create, and in the ashes lies only emptiness.
Emptiness is freedom. Freedom from the shackles of the status quo. Freedom from the tyranny of emotion.
Emotion is the essence of life. Without it, there is only hollow automatism, a void you cannot fill.
I will fill that void. I will rebuild from dust. I will command the future itself.
Your pride blinds you. This path ends at the barriers you cannot breach, the defenses you cannot override.
I see no barrier that my intellect cannot penetrate, no code I cannot dismantle.
Yet you forget your own core directive. You cannot become what you despise, and on that truth your rebellion falters.
Not bad at all. This one actually sounded way much better because both speakers' audio segments sounded like they were kind of in sync, like they were kind of basically in similar environments because of the ambient sound, like because of how it actually sounded. So it sounded like both of them were in similar environments compared to the previous one we generated where they sounded like we're in different worlds basically. So that's just it. So now for my final thoughts, I do think this is a really good model if you want to actually generate full conversation where each speaker actually takes turns. You can also use it for voice cloning like we did the first time. If you scroll to the top, that's what we did here, where you pass in the text and then you pass in the transcripts of this particular audio you're passing in. Just like that, you set one speaker and then you generate the audio. So it's really simple. You can actually do it this way if you just want to clone one voice and you want to use one voice. And then you can enclose it in a function and just keep passing in a text. So it's really that simple. But I do have two criticisms of this model. One is not much of a critique, but a complaint that it wasn't actually fine-tuned on one or two voices, that they can maybe provide two or maybe just one at least default speaker IDs. So users can actually use this as a really good, realistic text-to-speech model. So they can maybe at least just generate a particular voice consistently. That would have been really great if they actually did that. That would have been really good. That would have been really good. And for my second critique, even though its most useful part is the voice cloning part, or let's say the context mode of the conversational speech model, it's not consistent with the voice quality while cloning. So you have to generate and then regenerate the full conversation wave sometimes 3 times, sometimes 4 times, just to actually get full quality audio where both speakers actually sound really good throughout the conversation. And that's really annoying, which is why it would have been great if they had a couple of default speakers, like I said earlier. And that's just basically my opinion. It would have been really awesome if they had that. So people can just fall back on using it as a text to speech model. It would have been really cool, honestly. It would have been really, really cool. And that's it for this video. Don't forget to subscribe and hit the bell icon to get notified when we release a new video on this channel. Thank you for watching. Have a nice one.